Very good. Okay. What is this OSI model? So generally we can tell protocol and port number separately, and OSI model and TCP UDP differences separately, like, but we can combine also. Okay. So combining these protocol and port numbers in the OSI model itself. Okay. So we start with the OSI model. What is this OSI model? OSI model is a networking model. Is a networking model. It is a reference model. Before OSI model, there is a lot of networking models are there. Okay, IPX, SVX, AppleTalk, DoD model. This DoD model, now we are calling it as TCP IP model. So before OSI model, lot of models also there. Different organizations use different type of models. Okay, we are all commonly using TCP IP model. We are using TCP IP model. Remember this kind. What network model we are using? TCP IP model. Okay, protocol suite we are using TCP IP protocol suite or TCP IP model, which is old name is what is the actual name? Old name is DoD model, Department of Defense model. Okay. And our LAN net communication purpose, we are using UTP cables. Okay, UTP cables we are using. Like it's like not fiber optical, we are not using for LAN communication. Okay, so even so, why it is the purpose of learning OSI model? Open system. Open system means any kind of network model in organizations. Different organizations use different type of model. Most commonly, we are using TCP IP model only. Okay. In organization, what are the network model they are using? What are the vendor type of devices they are using? Means hardware devices, operating system, applications, network devices, cables, whatever it is, what model they are using it is, what type of communication they are doing it. Okay. This OSI model is applicable. Means understanding of OSI model help you to understand your network. Understanding of OSI model help you to understand your network. It help you to maintain your network. It help you to troubleshoot network related issues, irrespective of what network model an organization using, what hardware they are using, what vendors hardware they are using. Like I may use a Cisco router or Juniper router. I may use a Windows server operating system or Linux server operating system. I may use IPv4 address or IPv6 address. Okay. So like that, what are the vendor, hardware, software, or network model we using? So this OSI model is help you to understand your network and help you to maintain the network and troubleshoot the network related issues. This OSI model contains 7 layers. OSI model contains 7 layers. And these 7 layers, the standardized by this OSI model, standardized by ISO, International Organization for Standardization. Okay. So I said OSI model is 7 layers. What are those layers? Application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. And the layer numbers are like this. The layer 1 is physical layer. Layer 2 is data link layer. Layer 3 is network layer. Layer 4 transport. Layer 5 session. Layer 6 presentation. Layer 7 is application layer. These are the 7 layers. So, 7th one is application. The first one is physical layer. But when we are telling about OSI model, we'll tell generally from application to physical layer. Guys, if you are already learned OSI model in your academics, colleges, or maybe from outside courses, YouTube videos, if you learn in this sequence, like application to physical layer sequence, good. Or if you learn from physical to application, means your hobby, already you learn and you're already a good hobby of telling OSI. What are the OSI layers? You learn already like a physical layer, a data link layer, network like that. Okay, no problem. Keep it like that only. No problem, guys. There is no right or wrong here. It's not like that it is. Okay. Both are same. Application to physical layer to application layer, both are same. But thing is, when you are sending a data, okay, you are sending, it is application to physical layer. When you are receiving, it's a physical layer to application layer. Certain textbooks they give, starting is application layer, then it go up to physical layer. In some textbooks, some materials shows physical layer to application layer. So only difference is when you are sending, it's application to physical layer, and when you are receiving, it's physical layer to application layer. But do not interchange the layers. Okay, do not interchange the layer pattern, but you can go with any pattern. If you don't know this one or you don't remember anything before, so you can follow application to physical layer. It's quite easy to understand. Next. We discussed about networking devices, right? What are the networking devices? Hubs, switches, routers. In hub is layer 1 device, which is layer 2 device. Router is layer 3 device at home. So these are those layers. This OSI model application presentation session called as software layers, upper layers. Network data link and physical layer called as hardware layers, bottom layers. This transport layer is heart of OSI model. It provides end-to-end connectivity. Okay. So now we're going to see layer by layer. Okay. Got it? First is application layer. Application. So when you say application, it's all about application only. Okay. Not a specific anything. It's application. I'm using Chrome browser. It is an application. Okay. It is an application. I'm using Microsoft Teams to communicate it to you. It is an application. Right? I have Outlook. Outlook is a mail client application. It is also an application. I have a putty application used for remote connection purpose, remote server, remote Linux or Unix server access purpose using SSH. So putty is an application. Okay. So these applications, different applications. So you can see FileZilla. Okay. TFTP. These are FTP related applications. Okay. File upload, download purpose applications. MSTCS is RDP related applications. Okay. These are all client side applications. Do you want to access a website? You need a web browser. You want to access some mails? You need an Outlook. You want to access a remote server? You need a putty or a mobile extern kind of applications or putty related applications, right? SSH client applications are required. You want to upload or download files to remote server? You need a FTP client applications. Like that, application layer is talking about which application you are using for what type of communication. For what type of communication, what application you should use it. But you are using it. First one. Second, you are accessing a website using a web browser. Web browser is an application. You are accessing a website. Where is this website? In the web server. Web server provide web related services. From that one, you're accessing web pages. In web server, there is a web server application is there. Example, it can be a Tomcat web server, it can be a HTTPD or NGINX, Microsoft IIS. Okay, these are applications installed and running in the remote server. It becomes web server providing web pages. You're sending and receiving mails, right, from your Outlook. So to handle this mail communication, right, from the mail server, you're accessing mails, you're sending mails and receiving mails. So there is a mail server. So mail server also having a mail server applications, Microsoft Exchange application, Zimbra application, Dovecot application. Okay, these applications helps to these applications provide mail-based communication, mail services. Okay, same thing. You are want to access my remote Linux machine through SSH protocol. I use PuTTY application to access my remote Linux machine. But from where? From SSH server. Your Linux remote Linux service, SSH server provide SSH based connectivity. Means these applications, each application for different types of communications purpose. Okay, without application, how we will communicate? So we need a communication. You have a WhatsApp application, Instagram application, Facebook application. You can use it access to web browser or through application you can use. So that is the first thing in a OSI model is about application layer. It's talking about application. With application, what you are doing it? You are accessing data, right? You are sending or receiving data or information or resources kind of stuff, right? To communicate in the network. So we are communicating in the network. So what is the communication? Sending mails, sending messages, sharing of data or resources kind of stuff. So using different applications for different types of communication. And you're sending and receiving application through application. So sending and receiving information, data, or resource access through applications. Okay. So different types of communications, different applications. Plus application layer also about what protocols you are using. Depends upon what type of communication we should use that related protocols. What is protocol? Protocol is set of rules in generally people will tell, but protocols actually defines what type of communication. So I'm in a web browser, I'm accessing a website. Okay, I'm accessing a website. So it is STTP protocol. Okay, so I'm using it, put the application and connecting my remote server using SSH protocol. Okay, so to whom you are communicating and what type of communication, it should be understood by the protocol. Okay, the protocol. For example, I open a tpoint.com, right? tpointtech.com. I open command prompt. Two times it is. Okay. So for example, I put a I'm getting some kind of ping reply. But same thing, some kind of reply I'm getting, right? But same thing, I put it in a browser, I'm getting a page. So both are I'm trying to connect it to www.tpoint.com. But here I got some kind of reply messages. There I got a web page. So what is the thing happen? So in using ping, I use ICMP protocol and send echo message to the www.tpoint.com server. So this is used to test the connectivity between source and destination. So when I send using ICMP protocol, I send ICMP protocol echo request. Other side, the tpoint.com server understand the request and giving reply to me. It's a ping reply it is giving, ICMP reply. Again, I open this www.tpoint.com with HTTPS protocol. So what happened? Request is sent to the tpoint.com server. HTTPS request is sent. Then it is providing HTTPS response. So the page is displayed. So what application and what protocol you are using. Based on what protocol you are using, you are able to do that type of communication. So protocols defines what type of communication. Protocols using with the help of protocols, we can understand what type of communication between the devices or client and server. Based on the protocol only, it will understand what type of communication you want to do it. Okay. So here is some protocols and port numbers are there. So we understand the things from protocol names, but system understand with the port numbers. Okay. These are some of the commonly used protocols and their port numbers are mentioned in this document. HTTP, HTTPS, both protocols used for web-based communication. HTTP, HTTPS, both are for web-based communication. HTTP port number is 80, HTTPS is 443. HTTPS meaning is HTTP or SSL, secure socket layer. Okay. So if your your website is it's a web-based communication, its website is HTTP site. It means there is no data encryption. It is a HTTPS data is encrypted. Means what are the data you are sending and receiving is totally encrypted. Okay. HTTP is data is not encrypted. Sending and receiving is not encrypted. Okay. So HTTPS is secure because data is encrypted for SSL and TLS. Okay. FTP, File Transfer Protocol, default port numbers are 2021. FTP protocol are used for uploading, downloading files from FTP servers. SSH protocol, SSH, TELNET, RDP, all these three protocol for remote access purpose only. SSH by default it is encryption is there. It is for use for remote access with encryption. Port number is 22. Telnet by default no encryption. Port number is 23. It is also used to access remote system, remote access purpose. But SSH and Telnet both are CLI based. SSH is secure, encrypted formatted. Telnet by default no encryption. But both are a CLI based, CLI command line interface based connection. RDP, Remote Desktop Protocol. Port number is 3389. RDP, port number is 3389. This is also for remote access purpose only, but the entire desktop environment we are using, mainly used in a Windows-based systems. So GUI-based remote access. SSH Telnet, CLI, RDP is GUI. Entire desktop environment, remote system, remote Windows machine or a Windows server, desktop or server, we can entire desktop environment we can access. That is RDP. Of course, it is encrypted. Okay, port number is 3389. SMTP POP3 IMAP. SMTP port number is 25, POP is 110, IMAP is 143. SMTP protocol used to send a mail. You compose a mail and you click on send button. What happens? So you given from address, true address, and your message, and you click on the send. So what happened? SMTP protocol is attached. So your remote device understand your request, you want to send a mail. So it is SMTP. You open a gmail.com, you log in. So what happened? It send a IMAP request to the server. So if the server understand you want to read your mails, you want to get a mails. So that will understand. Even the POP3 is same. POP3 and IMAP for retrieval purpose to receive your mails, incoming mail server protocol it is. SMTP is outgoing mail server protocol is for sending mails. SMT port number is 25, POP3 port number is 110, IMAP port number is 143. TFTP, Trivial File Transfer Protocol, it is also transfer protocol, file transfer protocol, but TFTP, trivial type. It's not for transferring general documents or pictures or anything. It's not a file transfer. It is configuration files. To backup remote device or a server's configuration files, backup the configurations, okay, or configuring multiple devices, okay, like installation of an operating system into 10 systems. Use TFTP protocol. Remote configuration, uploading, downloading, configuration files purpose. DHCP, Dynamic Host Configuration Protocol. It's a protocol, port number is 6768. Guys, sometimes protocols, port numbers are 1, sometimes 2 also there. Okay. DHCP 6768. Assign IP address to client devices. What is the DHCP server will do? What is the purpose of DHCP protocol? It is a request. I want an IP address to the server. Server provide an IP address to the client. Okay. So that's a DHCP protocol. DNS. Very interesting. Just I open tpoint.com, right? As we know, all communications by IP address. If you know the IP address, then you will communicate. If you don't know IP address, you put just a name, if you cannot communicate. But we are using names only. Where we use an IP address for youtube.com, facebook.com, tpoint.com, google.com, gmail.com, whatsapp.com. Okay. We are not using any IP addresses. We are using names only. So what happens? A request will send to the DNS server and to find IP address of these things. IP address of youtube.com, IP address of this. So the request sent to the DNS server to get a IP address of that devices. tpoint.com IP address, microsoft.com IP address, facebook.com IP address. From where you will getting? From DNS server. NTP, Network Time Protocol, port number is 123. You see my date and time. This date and time is continuously synced with the time server. So my time server is here, time.windows.com. Time.windows.com. So my time is directly synced with this and time.windows.com. The protocol is NTP. So certain organizations, so what they do, they strict follow one type of network time protocols to avoid the mismatching of encrypted based communications. KERBEROS and LDAP. These are authentication and authorization based protocol. You log into the system and who is going to verify your username and password? So that is authentication protocols. KERBEROS and LDAP. KERBEROS mainly used in a Microsoft Active Directory services. In Microsoft servers, for a Microsoft Active Directory services, this KERBEROS is used. LDAP is a open protocol, so not only Microsoft, other devices also use LDAP for authentication and authorization. SNMP, Simple Network Management Protocol. Port number is 167, 162. This protocol used for monitoring purpose. So gather your remote systems, their status information. Okay. So these are the main protocols and their port numbers. And for certain services and applications also use for connecting port numbers. For example, I have a remote server. I send a request with a remote server IP address protocol 3306. Okay, this protocol port number used for to connect the service MySQL server. If that remote system having MySQL server application, then it will connect. Otherwise, it cannot connect. Okay. So, for example, my remote server is a web server, mail server, and MySQL server also. So, my request is 3306. It will connect MySQL database server. Okay. If I send port number 80, so I will connect it to web server. If I use SMTP, so then it is connected to mail servers. So these are protocols and port numbers are used to connect their services. Okay, their services or applications. So this is protocols and port numbers. Of course, at application layer itself, what application you are using based on what type of communication. And also we use at application layer time only. At application layer only, we should provide what kind of protocol we need to be connected. Okay, what kind of protocol? See, in a web browser, I specified what is that? www.facebook.com. Sorry, https colon slash slash www.facebook.com. Okay, like even YouTube, www.youtube.com, https colon slash slash www.youtube.com. Some specifying protocol. Okay, so maybe directly or indirectly we'll specify the protocol at application layer time only, means one application only. So this is your application layer. I said now application layer and transport layer little bigger, remaining are small, easy. But everything is important. They may ask you, tell me 7 layers of YSA model. Tell me about YSA model. Okay, or a specific layer, a specific PDU. Also, they may ask. Next, presentation layer. You have to present the data, right? So after application layer, what application you are using, for what type of communication, and what protocol you are using based on what type of communication. Now in the presentation, you're sending a data, means your data can be, for example, you send a mail. So in the mail, your data can be a text, HTML format, PDF format, DOCS format. Maybe there is a JPG photos, PNG pictures, MP3 audio, or MP4 videos. Okay, GIFs. We can send it. What are the data format it is? It will be converted into ASCII format. That is called encoding. When you're receiving data, you receive ASCII formatted data, it will convert into original data format. That's called decoding. And the data is higher size. You compress the data and send it. but when you receive, you decompress the data. So when you are using encrypted based protocols like SSH, HTTPS, okay, so then data will be encrypted. So when you are sending, when you are receiving, data will be decrypted. This is a presentation layer. Presentation layer is always about presenting the data. So first is application layer, presentation layer, session, transport, network, data link, and physical layer, right? This application layer has a data. Okay. So what are the application layer data? In the layer wise data, we call it as PDU. PDU means every layer data name is PDU only. Okay, the PDU is in the application layer called data. Okay, data. In presentation layer, what are the data is here in the application layer data, it will be encoded, compressed, and encrypted. Okay, so this data change. So then the PDO at presentation layer, the data name is data only, nothing more. Because your data as it is, only thing is it is encrypted, compressed, okay, and yeah, converted, encoded. Okay, that's it. Session layer. Session layer, the lines are only two, but very big role of session layer is there. The session layer it create a session for you. So you maybe in one browser I'm accessing YouTube.com, another browser I'm using Facebook.com. What in our system happen in session layer, it create a session for everything. So it will maintain the multiple sessions. Okay, multiple sessions. So the session layer maintain the session. It create a session ID. It attach that session ID to your data. Okay, it is created a session ID and attach session ID to your data. It maintain the session. Okay, this for maintain this and terminate the session once session is completed. For example, I open tpoint.com, right? So after some time, means maybe 5 seconds or 10 seconds, it displaying a page. So page is completely loaded, means the session is completed. You refresh the page or you open something, new session is created. Sometimes it will add it to the previous session. So session layer, create a session ID, attach it to our data, creating a session, maintain the session, and terminate the session. Okay. So here is an example, guys. You went to a shop and you buy something. You want to pay with your QR code, like Phone Pay, Google Pay. You open it and try to things like you scan the scanner QR code, enter the amount. Okay, first when you scan it, it will show your vendor details. You enter the amount and you click on confirm. Okay, then it will ask your bank details. You provide bank details. That's it. Yeah. So you scan the QR code. What is the next step? So you see the vendor details. You type the payment amount. Then it will go to the banking. So select the which bank you want to, from which bank you want to pay. Select that bank. Okay, bank will verify your authentication and how much is amount. It will be detected from your bank. And for authorization, Okay, again, for authentication, it asks you to PIN number. Once you give it a PIN number, it will authenticate your account, detect the amount from your balance. Okay, and it transfer that information to the vendor's bank. From the vendor's bank, it will give the information to other person. Now, you receive transaction successful. They received money is sent from this particular person. Okay, this is entire process, right? This entire transaction from your scanning of QR code, typing amount, and entire transaction has to be completed in the same session only. If session is changed in middle of amount transaction, session may be failures. It will be created dilemma, that is your really amount is detected, not detected, like that. Okay, the session late. So that's why when you have done any payments, while in a payment is going on, okay, it shows a message. Okay, do not refresh or press the back button or close the application. If you do it and when my payment is going on, so what happen? You will get connected to a new session. That session and this session will confuse and not connect. Okay, this is about your session layer. What is the PDU of the session layer? Is nothing but data one, because I'm not changing my data, just maybe some modification, but not complete data is not changed. The PDO of application layer, presentation layer, session layer is called data only. Transport layer. Now the thing is start. Transport layer. Now you are having a data. This data will be chopped into small pieces. Okay. This data is chopped into small pieces. Okay. What are the data it is? It will be chopped into small pieces. Like, okay, small pieces called segment. So these are the segmented data. The process of chop the data into small pieces called segmenting. So in that segmenting, you divide your data into small pieces. So this is segmented data. On the segmented data, it will attach segment details. Okay. It will number and sequence order. Numbering and sequencing of segmented data, it will do it. Transport layer. Segmenting and numbering and sequencing on sequence number on the segment. Okay. So now this is the segmented data. In transport layer, it take each and every segmented data like this. This is my segmented data. It attach segment number, segment or sequence number to the segmented data. It attach segmented data. Sorry, to segmented data, it attach a segment sequence number and total number of packets I'm sending, right? I'm sending not one by one, I'm sending multiple. How many I'm sending? Called window size. Called window size. So that window size, for example, I'm sending 10 packets at a time. So that is I mentioned here. Next, we discussed about a protocols, right? So these protocols are TCP type protocol, UDP type protocol. So here it will mention this protocol's port number. Okay. In the transport layer, it is having things. What are the source and destination protocol? In that one, it is divided. These are the TCP type protocol, put it in a TCP box. And when you're also send like UDP protocols in the UDP box. This whole part we call it as a TCP header. Okay. So TCP header is added to your segmented data. That TCP header contains your TCP UDP protocols, source and destination protocols information, plus number of packets you are sending and the sequence number of the segment is attached. This whole part we call it as segment. Whole part we call it as segment. Okay, guys. Anyway, what is this TCP UDP? It's a very important universal question type. It is okay. TCP UDP. Okay. What is TCP? There are a lot of protocols we discussed. HTTP, STTP, SFTP, NTP, like that, right? So like that, different protocols. Some protocols comes under HTTP. So, sorry, some protocols comes under TCP. Some protocols comes under okay, okay, yeah. SMTP. My mind is not stable. HTTP, SMTP, FTP, like this. Certain protocols are TCP type protocol, transmission control protocol. Some protocols are UDP type protocol. User datagram protocol. Example DHCP server. E, um, TFTP. TFTP protocol. DNS, also UDP type protocol. A DNS is TCP as well as UDP protocol. What is this? TCP type protocol, UDP. We are using different protocols. Some are TCP type, some are UDP type. TCP type protocols are reliable protocols. Okay, reliable protocols. Okay, connection oriented protocol. UDP protocols, non-reliable protocols, non-reliable, and connectionless protocol. Okay, so once again, TCP UDP, transmission control protocol, user datagram protocol. Some protocols are TCP type, some are UDP type. TCP type protocols are reliable, connection oriented. UDP protocol, non-reliable, connectionless. Why? Because of TCP protocols use acknowledgement and there is no acknowledgement in the UDP protocols. What is the acknowledgement is when you sending a data source to destination, source send a data to destination, destination receives a data packet and give an acknowledgement to the source. It means source understand destination is received a packet. Like when I send a data to destination, destination receives and provide an acknowledgement. So then, uh, so source knows destination is received data. For example, I send a data to destination, destination not give any acknowledgement. Means source thing, destination is not received because source not received acknowledgement from the source, from the destination. So source thing, destination is not received. Packet is not received to destination. So what it will do, it send the packet again. It send the packet again and we receive acknowledgement. Okay, this is TCP time. So because of this acknowledgement use, we know it's guarantee destination is received. So it's a acknowledgement based. That's why source knows destination is received. So it's a reliable protocols. It's a connection oriented. Okay. So that's it. It's UDP protocols, source and destination. UDP protocol will send packet to destination. Okay. But destination not sending any acknowledgement to the source. So source don't know destination is received or not. For example, destination not received a packet, we don't know. So then we'll continue sending one by one. We don't know destination is received or not. Okay. So TCP UDP protocol, connection oriented, connectionless, acknowledgement based, no acknowledgement based, reliable, non-reliable protocol. Some protocols are TCP type, some are UDP type protocol. Okay. TCP type protocol, when packet is sent to destination, destination give an acknowledgement to the source, source understand destination is received. Coming to UDP protocol, it does not check destination is available or not because it's a connectionless. Okay, it send a packet to destination. That's it. The source don't know destination is received or not because we don't use any acknowledgement. Okay. Yeah. But guys, some people ask like wider wireless kind of stuff. Here, no. Wider wireless, TCP is TCP, UDP is UDP, protocol is protocol. Wide and wireless is just for connection. So this connection oriented and connectionless represents the protocols verifying the destination is available or not. Distribution is getting IP address or not. That's what is connection oriented. That is connectionless. Okay. Again, so from session layer, the data is chopped into small pieces called segmented data. To this segmented data, we are attaching TCP header. In this TCP header contains segmented data, sequence number, number of packets we are sending, and what are the TCP type protocols and UDP protocols, their port numbers, source port number, destination port number of TCP, source and destination port number of UDP mentioned here. This whole part we call it as segment. Okay, this is network. Up to in the network layer, what happened? In the network layer, your source IP address and destination IP address is attached to your segment. Okay, attached to your segment. Guys, I told directly the source IP, destination IP. Actually, it will add logical address because OSI model is not about one pattern. Where you will get this IP addresses part. TCP IP protocol use IP addresses. Remaining protocols use their own kind of addressing system. Okay. So generally we are using TCP IP. I am talking in that manner. So source logical address is added to your segment. Okay. And also routing information. Routed information, routing information. Routed information means source IP address, destination IP address, specification. Routing information means which way packet has to be sent. So my packet has to be sent through my Wi-Fi adapter or maybe any other adapter. For example, I have a virtual machine connected to my virtual adapter. The packet has to be sent through that virtual adapter somewhere. So which way the packet has to be sent? Okay, what is the your default gateway? Or what is the system? One second. Okay, guys. Okay. So routing information means how the packet has to be sent. So this part is called a network header. So network header is attached to your segment. Okay. Source IP, destination IP, routing information. So this total we call it as packet. Packet. Okay. Now data link layer. In data link layer contains two sublayers. One is LLC, another is MAC layer. LLC, logical link control, which two ways they will tell. One is it link between upper layers to bottom layers. We use LLC. Another one is your WAN protocols. You are sending data over WAN link. Then WAN protocols information is added. Okay. So that is a thing. Okay. Like what are the WAN protocols? SDLC. SDLC is one of the WAN protocol. PPP. Now another protocol also there. PPP OE also there. Point to point or Ethernet. Frame relay. Frame relay protocol. MPLS. Multi-protocol layer connection. Okay. So these are different WAN protocols we are using. Second is MAC layer. MAC layer as a, MAC address. Media access control. So in a MAC layer, we are adding source MAC address and destination MAC address plus your packet, and we are adding checksum data. CRC checksum data. What is CRC? Cyclic redundancy check. It's a data checksum data is added. Data checksum data to verify the data at destination. So this is called a data tail. And adding a source MAC address, destination MAC address. This is data header. Is added to your packet. This is, we call it as frame. Okay, frame. So this frame in physical layer, the frame convert into the frame is convert into bit stream. What is a bit stream? Binary streaming. Okay, it's convert into bit stream. Now, how you connected physically? You are connected through Ethernet. Okay, using Ethernet NIC. You are connected to Ethernet. It means you are using UTP cables, copper cables. So signal is electrical signal. Signal is electrical signal. For example, you are using HBA adapter. Adapter is HBA adapter type. It means cable is fiber optical cable. Fiber optical cable. The signal is light waves. It converts the signal into light waves. Ethernet like this. Okay. For example, if it is a Wi-Fi, so you are connecting your adapter is Wi-Fi adapter. Okay. So signal is radio waves. Okay. So in a frame convert into bit stream. Again, this bit stream depends upon what type of media you are connecting. It convert into that signal, related signal. So this is your OSI model. Okay. This is your OSI model. Application layer, presentation layer, session layer, transport, network, data link, and physical layer. Once again, guys, application layer is about a application, provide a service like a what type of application we use to communicate, what based on what type of communication, based on that what application we should use. And based on what type of communication you're doing, we have to choose our protocol. Based on what type of communication, we use that related protocols. So application, client or server side applications, protocols and port numbers, we use in an application. Of course, you're sending mail or accessing website or providing web services, anyway, you're sending wise, right? So data, you're sending data or information is in the data format, right? Whatever it is in the format, it is encoded and decoded. Encoded, it means it convert into ASCII format. And data will be compressed, encrypted. Okay. And a session layer, it create a new session for every time you're communicating to something, you create a new session. And it attach that session ID to your data. And it maintain the session till the transaction is completed. One transaction completed, it terminated. Plus, in the session layer, there is authentication and authorization information is also added about who are you. You are anonymous user or specific user. What is your authentication details, identification details. So it will also attached. Okay. So the entire transaction should be completed within the same session only. You're downloading a data. So like for example, you download 100 MB file. This entire 100 MB file has to be downloaded. In case you are already downloaded 90 MB data, suddenly your browser is closed or internet is disturbed. So your session is waited. It is failed. In the transaction is not completed, failed. Again, you have to re-download it. Okay. So session means once you open, so it will be completed. Some of you are, I think, seen this percentage, right? Like you know, online computer exams. Whenever you start, session is started. And you, whether it is 1 hour or 3 hours exam, within that exam time, it should be completed. Once you are submitted, session is completed. Okay. Right. Once 3 hours completed, session is completed, disconnected automatically. Okay. This is where about a session is. And not only that, into the session ID, all your data, it is maybe in different locations, it will be attached the different information to your session ID. Transport layer, we provide end-to-end connectivity. Okay, transport layer, chop the data into smaller pieces called segmenting. The process is called segmenting. To segmented data, it attach numbering and sequencing. Numbering, sequence order numbering is there. Okay, numbering and sequencing. And also, what it is, you are using different protocols to communicate. So what is your source protocol and destination protocol? So we'll attach in TCP and UDP manner. Some protocols are TCP type, some are UDP type. So TCP type protocols mentioned in the TCP, what protocol, source and destination protocol. UDP protocols, their port numbers mentioned under UDP. Yes. Okay. TCP protocols are connection oriented, acknowledgement based, reliable protocol. Whenever source send data to destination, so destination send acknowledgement, source knows destination is received. If source not receive an acknowledgement from the destination, source will send the data again. Next is UDP, user datagram protocol. It is these UTP type protocols are non-acknowledgement based, non-reliable connectionless. Means source send data to destination, whether destination is received or not, source does not know. So it will keep sending the data. Because of this acknowledgement in the TCP, so compared to the UDP, TCP is slower, but it is reliable. Okay. So this source and destination TCP protocol port numbers, UDP protocol port numbers are attached to your segmented data. And number of packets you are sending So that information also attached. That's called TCP header. So TCP header plus PDU from the session layer, the total, the data from session layer and TCP header combined is called segment. That segment is sent to the network layer. In network layer, routed protocol means logical addressing. Routing protocols means routing information is attached. Okay. So network header is attached to your segment. The network header contains source IP address, destination IP address, routing information is attached to your segment. The total we call it as packet. Okay, the packet is sent to the data link layer. In data link layer, so two sublayers. One is LLC, logical link control, PPP, SDLC, frame relay, MPLS. These are the different WAN protocol. If you are sending data over WAN link, so WAN link information also added. Your WAN information is also. If you are sending over LAN only, in internal only, then it is MAC information is added. This is a MAC address. We know already it's a 4018 binary. Okay, represented in 12 hexa numbers, also called as physical address. Source MAC address, destination MAC address attached to your packet, plus a data tail is CRC, cyclic redundancy check. Checksum data is added. Whenever destination receives the data, it uses that CRC value to verify your data. This data is valid or corrupted. The total PDU we call it as frame. That frame is sent to physical layer. Frame convert into bit stream. Depends upon what type of physical connectivity you are using. That physical adapter and as well as the physical connectivity. Okay, so it will convert into that signal like electrical signal or radio signals or fiber. Okay, so this is about your OSI model, guys. What is this? So when you are sending source PCA, destination is PCB. Okay. So from here, first you are sending application, presentation, session, transport, network, data link, and physical layer. When you're receiving physical layer, data link, network, transport, session, presentation, and application. Okay. I will stop here. Tomorrow we'll start from here, like source and destination wise. Otherwise, we'll go with TCP IP protocol suite and OSI model comparisons. Using OSI model, what are the troubleshooting related? What are the networking commands also we'll discuss tomorrow, and network checking connectivity. We have a time, then we're going to see about the Wi-Fi configuration, internet related troubleshooting guys. Depends upon time. Also, that is also direct questions, guys. This is also ping is also direct questions. What is ping? They don't ask, they will ask other things. Okay. So I will stop here and make sure, guys, everybody be there and don't leave till the session today. I'm almost all there. Okay. That's a good thing.
Sir, is there a class on Saturday?
Saturday, no sessions. As per now, no sessions on Saturday. Okay. Tomorrow we have a session. Not my sessions. Saturday.